There we go. Alright, so once the recorder is up and running, we can go ahead and take a look at that homework assignment. I have the original file already. I just need to start from scratch because I don't want to reuse the solution from the morning. Okay, so we have the folder and the basic program that you start with. So with this program, what you need to do is to find the maximum of the 4 variables. The command line will take in the 4 numbers and put those numbers into W, X, Y, and Z already. Max, MAX, is the name of the variable that will store the maximum of those 4 different values. So there are different ways to do it. So what I'll do is I'll give you 5 different solutions. Not that I'm expecting you guys to come up with 5 different solutions and turn it in as your homework assignment. But I want you to understand all 5 solutions because they only involve concepts that we have talked about in this class already. Okay. The first solution is, to me, this is the easiest solution. The easiest solution is to say, well, when we only look at one single variable W, we'll just say that, well, since this is the only variable that we have seen so far, let's call that the maximum. Okay, so it's an assumption and say that no, let's since this is the only variable that I have come across at this point, we'll just kind of assume that is the maximum. And then when we come across X, then we'll say, is X larger than the maximum that I have seen up to this point, which is just W itself? If the answer is yes, then we'll say, oh, okay, max is no longer the maximum because we have just seen a value that is larger than max. Let's make that the maximum. Okay, is that making sense so far?
Yeah.
And you probably can kind of guess, what happens next. Okay, because then we'll say, oh, now we come across variable Y, and if the value of Y is greater than the maximum that we have seen so far, then we'll go ahead and say, okay, max is now Y and not whatever it was before. And then the last one is we come across Z. If Z is larger than the maximum that I have found at this point, then I'll just make that the maximum. And that's it. That's the code. One way to solve this problem is to do it this way. Are there any questions about this particular solution? No questions? Okay. Now, the important part about this solution is the conditional statements are sequential. In other words, I actually have 3 conditional statements to evaluate in this case. It is evaluating one after another. They're not nested in any way. They're just sequential, one after another. All right. So if this solution is done, so we'll go ahead and test it first. G++, and I'll do a really quick one because I know this one should work, so I'm not gonna compile it with debug information. So I'll just go ahead and compile to the executable and run the executable with those numbers. Okay, so 54 is the largest one, is the maximum, and it still works when you have 2 maximum. Okay, that should still work. Any questions about this? I think last time somebody asked, can we have negative numbers? And, that should work too. Okay, so if you have negative numbers, then you can have -4, -5, and let's say -10 here. So out of these negative numbers, -1 is the largest one. So that should still work. All right. Any questions about this solution? Say again?
Is that negative one?
Yeah. Is there any way to maybe?
Screen, you can't see it.
Okay.
Because it looks like 4, 4, 4, and 1.
Okay, because
It does look like positive 1.
there we go.
There we go.
Thank you. I didn't know the screen was off.
Yeah, it was code for all the rest of them.
All right. So, any other questions about this solution? Okay. Now let me just kind of copy this one to another file, and then we'll work on an alternative solution, which is kind of similar to this one, but without the use of conditional statements. Instead, it makes use of the ternary operator. So to use a ternary operator instead of a conditional statement, we still have the basic components. In other words, we still have the condition, and if the condition is true, then x is the maximum. If the condition is false, then maximum is already the maximum, so we just assign that back to itself, because you cannot say, oh, let's stop the assignment operation. You cannot stop it. You can specify the same value on the right hand side, so effectively we are not changing max itself. Okay. So the condition here is to ask the same question: is x greater than max? If so, return the value of max as the ternary expression value, and that will be used to update max. If the answer is no, if x is less than or equal to max, then max is already max, and there's no need to return x. So I can now remove the other way. So the other ones are basically the same thing. So we just look at y and z instead, and update the expression with y or z accordingly. So this is the alternative version based on pretty much the same logic. There's not much of a difference. It's just instead of using conditional statements, I'm using a ternary operator or expression in this case. Are there any questions about the use of the ternary operator? No questions. Okay. If there are no questions, we'll go ahead and save this one, and double check, actually compile and run the program to make sure that it runs to a certain point. Okay, 2, 3, 4, 5. So 5 is the maximum. 2, 5, 4, 3. 2, 4, 4, 2. 4 is the maximum. 5, 4, 3, 2. 5 is the maximum. Okay. Now these are only test cases. Even though the program worked for all of these test cases, at this point there's no guarantee it will work for the next test case. Okay. And that's one of the problems of using test cases to test a particular program to see whether it is working correctly or not. Is how can you be sure that you have just tested your program with all the possible test cases? Or the other way to say it is, if there is a flaw in your program, how do you make sure that you have a test case to catch it? That's the question. In this class, this is cisp360, and I'm not going to talk about how to prove the correctness of a program. Okay, some people who took cisp300 from me, we spent some time to talk about how to prove a program is correct mathematically. Okay, we're not going to do it in this class. That's not the focus of this class. On the other hand, you should understand that there are techniques, there are methods out there that can prove the correctness of a program mathematically. So you don't have to use a single test case to ensure that your program is correct. But in this case, we have to throw enough test cases to be confident that the program is working. Okay. So now we'll move on and talk about another alternative, and this particular alternative is kind of interesting because it doesn't use sequential statements. Instead, it uses nested statements, like conditional statement within a conditional statement, to get to the maximum. So we'll take a look at this particular solution and make sure that we at least understand what it is. So this is line 44. So I will delete line 44 to here and start all over. All right. So with this particular solution, the characteristic is I only have one single comparison every time, and I only have one assignment to get to the maximum. Okay, so I will confirm that x is in fact the maximum before I say max equals x. I will confirm that w is the maximum before I get to max equals w, and so on. Okay, so let's take a look at this particular solution. You can pick any two variables and just do a comparison. As long as the comparison involves greater than or equal to, less than and less than or equal to, it will still work out okay. You might have to change the details a little bit to make it work, but the basic principle still works. Okay, so with this case, I have to use a if then else, okay, because the else case is actually important, and also here, because the program will get longer, okay, it will get long enough to the point by the time I get to this else here, I can no longer remember what is the condition of the else. So I'm going to use a comment here and say, by the time we get here, we know that w is less than or equal to y, or it is not the case that w is greater than y. And you will see why I need to do this later, okay? Because the program will get longer. Then I go back to here and say, okay, now that we know w is greater than y, I know y cannot be the maximum, okay? Probably should have used x just so that it is more sequential. Okay, I'm just using x here, sorry about that. But we know that x cannot be the maximum, so the only remaining choices would be w, y, and z. Those can be maximums, okay? So with x ruled out, I can now say, okay, I'll just kind of comment here and say x is ruled out. And then we can say, okay, let's compare w with the next variable. You can pick y, you can pick z, it doesn't really matter which one, but just to be more systematic, I'm going to pick y here. So once again, I use the basic shell of a conditional statement, and this one I don't need to comment because it's right after the actual condition of the conditional statement, so I don't need comments to remind myself, how did I get here. But if I get here, that means x is ruled out, y is out as well. Okay, I only got one choice left. Okay, is it w or is it z? Those two can be the maximums. So at this point, if I need to comment, I would say x and y are ruled out. So now I just need to compare w to z. If w is greater than z, then w is the maximum. So we just say max equals to w in this case. Else, max equals z, because those are the only two variables left that can be the maximum at that point. Now, with this else here, this is corresponding to w is less than or equal to y. So at this point, which ones are ruled out? X is ruled out, and I will go ahead and rule out w as well. Now the reason why I'm ruling out w is because w can only be less than or equal to y. Is it y? Yep. Okay, if w can only be less than or equal to y, that means I can rule out w. If w and y are exactly the same value and I'm still counting y in as a potential maximum, I will still catch it. So it's not like I will not catch the maximum in this case. Once I rule out x and w, I will go ahead and compare the other two, which is y and z. So in this case, I have to rule out y. I have to determine which one out of y and z is the maximum. So we say if y is greater than z, else. Okay. If y is in fact greater than z, that means y is the maximum. So max equals to y. Otherwise, max equals to z, like so. Are we still doing okay so far with this nested conditional statement structure?
Why can we rule out w?
Because w is confirmed to be less than or equal to y.
Because by the time you get down here, we've already determined that max isn't w up there. I don't see the line numbers on there, so I can't.
Yeah, this else is corresponding to this condition here.
Oh, okay.
So because it's the else of that, that means I have already confirmed that w cannot be greater than y. So w can be ruled out. All right. So now we go to the else of the outermost conditional statement, and with that, that means I have just ruled out w. So with w out of the way, we have three variables left: x, y, and z. So you just have to pick two to compare. Okay, we'll compare x and y here. If x is greater than y, then y is ruled out. So at this point, w and y are ruled out. And with the other one, we have just ruled out x and w. So getting back to here, now you can see why I wrote this comment earlier, because the program or this structured conditional statement is getting so long that I cannot see the top. I cannot see the condition corresponding to this else branch. So it really helps to kind of have a comment here to remind myself, by the time you get to this branch here, it means blah, 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 blah. Okay. So with W and Y both ruled out, then it's just down to X and Z. So we compare X to Z. Oops, I forgot the else here. So when we compare these two, X is the larger one, that means the maximum is X, else the maximum is Z. And then down here we have W and X ruled out, so we have Y and Z left. So we now compare Y to Z. And then we say max equals to Y in this case, because Y is the larger one. And then the other one is max is Z, because Y can only be as large as Z. Right. So that's the other approach. I mean, this obviously is the longer approach, and to some people it makes sense because if you look at it from the perspective of a decision tree, this one is actually easier to understand as well. Because with a decision tree, you just say, okay, I have one single comparison to perform, and out of this one single comparison, what do I know about the ordering of the variables? Okay, but each time you compare, you make a decision. Each time you compare, you make a decision. So it actually kind of makes sense to some people. It makes more sense than the other methods. But the question is, does it do the same thing? Is it correct? So we'll go ahead and give it a try. Oops. 2, 3, 4, 5. 5 is the maximum. And then we can give it 5, 4, 3, 2. 5 is the maximum. 4, 5, 3, 2. 5 is the maximum. 4, 3, 5, 2. And 5 is the maximum. Yes?
When we have two equal numbers, do you care that it's going to pick the second one?
Say again?
When we have two equal numbers and they're both...
Then it doesn't matter which one you pick, because it will print the same number, like this. So if it is 5, 5, 3, 2, the answer is just 5. I have no idea. From the outside, I have no idea which 5 he picked. And it really does not matter. Okay? All right, so that's the third method. I think, we'll have two more. Okay, 2 more ways to do it. So main3.cpp. So we now look at main3.cpp. Go to line 44 and find out where to delete. Okay. So with the third method, we are using something like this. So we are going like, okay, if we need to confirm that W is in fact the maximum, the other way is kind of really cumbersome and long, okay? Maybe we can just kind of shorten the logic a little bit here and say, hey, if W is greater than X, and W is greater than, W is greater than Y, and W is greater than Z, that means W is the maximum, right? So max equals to W here. And then we'll use the format of a multi-branch conditional statement. In C and C++, there's really no multi-branch conditional statement, but we can have the illusion that it does have multi-branch conditional statements. So the next one is going to do the same thing and confirm that X is the maximum. So now you can say if X is greater than W and X is greater than Y and and X is greater than Z, then the maximum is X. So we just have one more to go, same format, okay? Confirm that Y is the maximum. If Y is greater than W and I said one thing and type another, and Y is greater than X, and Y is greater than Z, then the maximum is Y. Well, what about Z? Well, by the time we get to this final else here, Z has to be the maximum, because we have just ruled out, by this time, we have just ruled out that W is not the maximum. Something is larger than that. We have just ruled out that X is not the maximum. Something is larger than X. And we have just ruled out that Y is the maximum because something is larger than Y. So by the time we get to here, we can just say else for catch all of the other cases because Z is the maximum. Yep. Well, that's the other thing. This is actually a faulty program, okay? Because I'm not using greater than or equal to. Okay, well, what is the big deal? Greater than versus greater than or equal to doesn't seem to make any difference in this case. Well, it does, okay? But what we want to do is to test this program first, because the testing of this program will illustrate another point that I want to make. But it's much better when you actually see it than me just talking about it. So G++-O main3 main3.cpp, and then we'll just run it like 1, 5, 3, 2. 5 is the maximum. 5, 1, 3, 2. 5 is the maximum. 1, 2, 5, 2. 5 is the maximum. And then 1, 3, 2, 5. 5 is the maximum. So what is the big deal here? Well, let's try duplicate values. 1, 3, 5, 5. That works too. What about 5, 5, 1, 2? Let's think about it, okay? Now, because I put it this way, it means something is not right, right? So if something is not right about this particular test case in this context, what do you think is going to be the output?
It's going to end up with the wrong variable, because when you go into the first couple of if statements, they're going to end up being false. And
Right,
it's going to
they
jump
all-
down
they
to
will
an
all be
assumption
false.
that the remainder is going to be one of the maximums, which would be
So it will catch, so
Z
it will
or Y.
so it will print which one as the maximum.
We print probably Z.
Yep, exactly. It will say 2 is the maximum of these 4 values. Well, let's confirm that first, okay? It did. So at this point, if your program is doing this, this is a good time to do one of two things, okay? One is kind of preferred, but the other one is not bad. One is to go back to your program and analyze your program analytically. Just kind of look at your program and try to use your mind to follow the flow of the program and figure out why it is not doing the right thing. But the second thing you can do, which is not really bad at all, I mean in this case, is to use GDB and follow the flow of the program. Because if you follow the flow of the program, let me go back to the program first. If you follow the flow of your program, you would think that it should go into either this case or this case, right? But when you trace the program step by step using GDB, it would evaluate this condition, then it will go here, and then it will go here. In other words, neither this condition nor this condition is true, overall speaking, okay? As a conjunction, it is not true. Well, then you look closely at your expression here, and then you will start to notice why it is not true. Because X and W are both 5 in this case. 5 is greater than 5 is
False.
false. So that's why the
False.
first condition of each conjunction is false already. That is also false.
So that whole statement is false because
With
of that.
conjunction,
Yeah.
you only need one thing to be false for the entire thing to be false. In fact, based on what we talked about last time, the lazy evaluation or short-circuited Boolean evaluation, this is all it takes. Okay, it will only evaluate this one single comparison, and because it is false, it doesn't even bother to do any other comparison. Okay, that's why the program is not working. That's why it failed to work. Okay, now there are several ways to fix it. The easiest way to fix it, from a certain perspective, is to change all the greater than to greater than or equal to. Okay, because if W is greater than or equal to all of the other variables, it is still the maximum, right? So that would be one easy way to fix it. So let me fix the program that way first. This is line 44. So I'll say 44 to this line, substitute greater than with greater than or equal to. So now I have all the greater than changed to greater than or equal to. The program is now fixed. Let's recompile and then run the program again and give it a test case that it failed before, which is 5512. And this time it printed the correct one. It fixed the program. All right. Any questions? Any other questions about this one? Questions? Okay. And I promise you that I will give you 5 different ways of doing the same thing. So here's the last one. The last one is the one that most people do not want to see, but I will give you. But I will give you this one. It's still only using concepts that we have learned up to this point. Okay, I don't want to use the pointer array, which is p-int. Now, if I use this one, I can just use a loop to do whatever that I need to do. So that would be the actually one of the fastest way to do things. But I would only use concepts that we have learned so far. So we delete everything and start from scratch here. So with this one, I use a single assignment statement to do everything. In other words, I say max equals 2, okay, in one single expression. But this expression is going to be a ternary operator, okay? So what we'll do is I'm going to structure it this way. Oops, not curly brace. The other part of the expression is so long that I'm going to have to use open paren on one line and close paren on the other line. Okay, so the first one is to just confirm that W is the maximum. But we just talked about that, right? So that's pretty easy. We just say W is greater than or equal to X, and W is greater than or equal to Y, and W is greater than or equal to Z. That's the condition that I want. If that condition is true, I will just go ahead and return W as the value of the expression, because I'm taking the value of the entire ternary operator expression and use it to update max. So this will do just fine, because I just found W to be the maximum and I use it to update max. What about this part here? Well, that turns out to be another ternary operator, right? So I have a condition, question mark. This time I confirm X is the maximum. Otherwise, I got some other things to do that is going to be a little bit lengthy. So how do I confirm X is the maximum now that I know W is not? Well, this time I got a little smarter. We say X is greater than or equal to Y, and X is greater than or equal to Z. I don't even bother to compare X with W anymore, right? Because once you confirm W is not the maximum, you don't need to compare against W anymore. So what do we do down here? Same thing. Okay, another ternary operator. This time we have some kind of comparison and conjunction and whatnot to confirm that Y is the maximum. But if Y is not the maximum, I don't need anything complex anymore, because at this point I have just ruled out that W is the maximum, I have ruled out that X is the maximum, and I just ruled out that Y is the maximum. What is left?
Z.
Z, yep. So at this point I can just say, oh, okay, the alternative has to be Z. So at this point I have ruled out W and X being the maximum. I only have Y and Z left. So what do I need to do to confirm that Y is the maximum of the two?
Y is greater than or equal to Z.
Yep. Y is greater than or equal to Z. Either way will work in this case. Okay. So this is another way to express the same logic, but this time I'm using a nested ternary expression to do it. But in terms of approach, it is almost the same thing as the previous one, except I'm using a ternary operator. You can also see that in VI, it's really nice because you can see the green cursor is where the cursor actually is located, and then the light blue cursor is the matching close of the cursor. So that's why VI in a way is really friendly, because it makes it easy to find matching parentheses and stuff like that. Alright, so let me save it and we'll go ahead and test it. G++-O main4 main4.cpp, and then we run it. We'll try 5 4 3 2, maximum is 5 4 5 3 2 3 4 5 2 and 3 4 2 5. So all of these worked. It's no confirmation that the algorithm is correct. It simply means it worked for all of the test cases that I'm throwing at it. Okay, are there any questions about this particular homework assignment?
Instead of using n, can we use or, like like or, and smaller than instead of greater than equal?
Use or and then change everything to less than? That is not gonna work. Because with an or, if one of the components of an or is true, then the entire or is true.
Change the greater than the smaller or.
Okay.
You could use less than ones. You just
Okay, if you turn all the greater than or equal to less than, and then you turn all the conjunction to disjunction, you still need a big old negation on the outside to make it work, because otherwise you can confirm that W can be less than one of the other ones, which means you know that W is not the maximum. So how is that going to help you? Okay. Okay, let me copy and paste and see if I can understand what you meant. Okay, so what you said was to change all of these to less than, and then change all of these to or. But that's not going to work, because that will only confirm that W is not the maximum. So you have just confirmed that we should rule out W, and yet we're using W to be the maximum.
So W is ruled out after the first step.
Right, but in this particular case, I'm using W as the answer.
How I define. The big long one.
But
It was the easiest to like understand.
Say again?
If a statement.
We can use what?
If instead of the statement.
If statement?
Yeah.
Okay, so if you're using if statement, okay, let me see if I can understand what you said here. So I'll delete all of this. Okay, so you have if W is less than X, or W is less than Y, or W is less than Z. Okay, what do we do in the conditional statement?
And we say that if the one of them is ruled out, then W is ruled out.
Because at this point we just rule out W.
So we can say if X is less than Y or.
So now you're by ruling out things you're trying to do it that way.
Yeah.
Okay, so what about the else here? What do we do with the else?
And else of the first one is gonna be max is equal to W.
Okay, yeah, you can do it that way. So you can say max equals W. Yeah, that will work. But then you also have another logic here to rule out X.
Yeah.
Yep.
Of X and then.
Yeah, you can do it that way. So so there are many different ways to get this done. I mean, for this particular homework, as simple as it seems, finding the maximum of 4 different variables, there are many ways to get it done already. Okay. What is if is anyone feeling stumped by the homework assignment at least at one point?
Code blocks is useless, I know that.
I had no problem with one.
It wouldn't run or build my program for some reason.
Are you sure you have the right version? Yeah, mine works just fine.
Okay.
I'll have to ask it in class.
So you have a tool issue basically. It's
Yeah.
a tool issue, not as much of a logic or program issue, but more like a tool issue. Anyone else? I mean, is anyone running into like the programming issue? Like the tool is working okay, but I'm not quite sure how to approach the problem, how to write the code. Nobody? Okay. Well, that's good to know, because your next homework assignment is going to be a little bit more complex. Just a little bit, not by much. This is your next homework assignment. You have 1 week from today to get it done. And this one is for sorting 4 variables. So when you click on it, it has kind of the same format. You are doing to download a zip file, unzip it, and then inside the zip file there will be a main.cpp. But this time, even though I still have my code to read 4 numbers from the command line, your job is not to find the maximum of those 4, but to sort the 4 variables that are w, x, y, and z. And on top of that, I didn't write it here, I should probably write it down as soon as possible, is you cannot use any extra variables. So you have the 4 variables, and there's no max anymore. I took out the definition of max because you don't need max anymore. My program, or my code, will print out w, x, y, and z at the end, so they should be in order already by the time it gets there. So w should be the minimum, and then z should be the maximum, and those 2 in between, are just in between. Okay. All right. So how do we do something like this? Okay. The rest of the description is already here, and I just talked about it, kind of verbal. So this is from the morning, but I can reuse this example. I just have to erase the rest of it. Okay, there we go. So we have 4 variables. So let's just say that when on the command line, 3, 4, 1, 2 are the numbers specified in that particular order. And we want the output to be, we want w to have 1, we want x to have 2, we want y to have 3, and z to have 4. So the question is, how do you systematically figure out, all this stuff here? And we are not using arrays, so any type of a lookup on Wikipedia on sorting algorithms is not going to be very helpful. I don't think Stack Overflow is going to have any answer to that either. All right. So how do we do something like this?
Can we just do this same thing we just did, except
Almost exactly.
except that we just say that instead of max gets this, we say w gets the final.
The assignment operation gets a little bit tricky. Okay, the assignment operation gets a little bit tricky. So since we already have talked about the logic of finding the maximum, let's just kind of use that. Okay. So what we'll do is we'll focus on z first, because z is supposed to be the maximum of these 4 variables. So you can use the same logic that we have talked about to find out who has the maximum. So the first few approaches where we kind of do a running maximum is not going to work, because what you need to do is to find out who has the maximum first and then do something about it. So use whatever logic you need to do, and eventually you will find that, oh, in this case, x has the maximum. It's supposed to be here. But you cannot have another variable as a temporary, so they can say, oh, okay, we have one more thing here to kind of to do the swap. So what are we going to do? We have to somehow exchange the value of x, which has the maximum, with z, which is where the maximum is supposed to go. So what do we do? In other words, I want to end up with x being 2 in this case, and z being 4. How do we do something like that? Does anyone remember question 2 of the mock exam? Yep.
Bitwise OR then? Bitwise OR.
Bitwise exclusive OR, exactly. So in this particular case, z exclusive OR x exclusive OR z, is it just twice?
Yeah, I know you got it.
Yeah, that should do it.
Well, the way you did on number 2, you had it like nested inside because you had to.
So one more time?
Yeah.
Yeah, I think that's it. You have to do it one more time. Okay, so with this, it will solve the problem. Okay, because this will exchange the values. Is that okay? Does everybody still remember that question? That we tracked it down and figure out what it does? Let me open up a new tab so we can just kind of revisit that particular question. It's question number 2 of the mock exam, and it's this one here. Okay. So instead of assigning the maximum to a certain place, you do this and exchange it with another variable. So this way you don't need a third variable, and yet you'll be able to exchange the values of 2 different variables. Okay? All right, so I'm just going to erase this one here. So now that you have Z taken care of, what do you do next?
Take care of W.
Yep, move on to Y. Move on to Y. Y is supposed to be the maximum of these three. So you basically do a simplified version of that logic and exchange Y with whatever has the actual maximum value, and then you deal with X and W after that. Yep, question?
Maybe another way to do it is, could we say, we knew which one the max is and knew which one the min is, and then deal with the middle case by itself?
You can do that. I mean, yeah, you can do it that way too. Yep.
How would you do that without having other variables? Just out of curiosity.
He will still have to use the same approach. I mean, the swapping part is still going to be the same. It's just that he's going to swap whoever has the minimum
Just
with
have to find the lowest.
where the minimum is.
I'm just
Yep.
trying to think how that works.
Yep.
They compare X and Y.
Yeah.
So does everybody know how to kind of approach this? It's going to be a slightly longer program, but it's not going to be too bad. All right. So this is your new homework assignment. You have 1 week to work on this. And now we can go back to the practice questions, because I have 2 more practice questions of how to write some code to get something done. So we'll go ahead and talk about those 2 questions. They are X1 Q4B and Q4C. Those 2 are the new, quote-unquote, new questions. So we'll focus on one at a time. With Q4B, you are given n as an integer value that is at least 2, and you have an initialized variable f. The objective of the algorithm that you're going to write is to write the code to find the smallest factor of n and store that factor in f. For instance, okay, if n is 8, f should be 2, because 2 is the smallest, the only factor of f. That's a bad example. Okay, let's try 21. Okay, 21 is much better. So with 21, n being 21, then f should be 3 and not 7, because 3 is the smallest factor of 21. Is that okay? With 49, it's 7 and 7, so it's just 7. All right, so given that is what you need to do, how do we approach this problem? How do we solve this problem? Well, you want to do it by hand first, okay? Do it a few times by hand so that you can get you get a feel of what needs to do, what you need to do.
Would it just be a counter and a mod operation?
Yep. Yep. For people who took my class, this is familiar because we have done it. But I want to make sure that everybody in the class also kind of get the general idea of how to approach this problem. So what you want to do, I'm using a spreadsheet to demonstrate the idea. You can do it on a piece of paper. But the idea is, if you are trying to do this, if you're doing this by hand, don't give yourself a trivial test case. Okay, something that's too obvious is not going to help. For instance, 100. Okay, if you say, okay, let's see if n is 100. How do I know? How do I find the smallest factor of 100? And it's not going to help, because in your mind, the moment you look at the number 100, you already know the answer. You don't have to go through any type of procedural way to get to the answer. So that would not be a good way to do this. You have to use something that you are not familiar with. Okay, pick a number that is not obviously a factor of all the common factors, then work on it. Okay, in the previous class, I picked this number, 5821. So I'm going to use the same number here, and some of you will find out why I kind of smiled or smirked when I mentioned this number. The smallest factor of any number is 2. 1 is not considered a factor. Okay, it's not considered a factor. The smaller factor is 2. So it's easy to tell whether this number is wholly divisible by 2 or not. All we need to do is to do a mod, right? The mod, which is a remainder operation. With a spreadsheet, it also has a mod function. With a mod function, you just have to specify which number is the dividend, the number being divided. In this case, it is the one in cell A1, so we'll say $1 to refer to cell A1. The dollar needs to be here because of something that I'm going to do next. But it is still referring to that number, 5821. the divisor is whatever is in B3, so I just specify cell B3 here. This is not an Excel spreadsheet class, so I'm not going to spend too much time to talk about the tool itself, but it gives me a 1 as a remainder. In other words, 5821 divided by 2 has a remainder of 1. Okay, as long as it is non-zero, it is not a factor. So now I can do something like this. Okay, we can say, what about 3? 5821 divided by 3 also has a non-zero remainder. What about 4? Attack, that is dumb. Because we just tested 2, so testing 4 is like not so smart. Well, it may not be so smart because it is wasting time, but is it incorrect?
No.
In other words, is it possible that in this process, by testing 4 as a potential factor of 5821, that I will misidentify 4 is in fact a factor? That won't happen, right? So as long as that's not going to happen, it is just wasting time, but it's not incorrect. Okay? Then we'll test 5. 5 is not there. 6, once again, is dumb. 7, not there. 8 is dumber because it is because we got 2 here and 4 here, right? So 8 is the product of that. Okay, but it is not wrong. The key is it is not incorrect. Okay. Now the nice thing is, you don't have to worry about how do I come up with a list of prime numbers, because I know most of you want to think, oh, we want to be efficient. We want to come up with a list of prime numbers and only test the prime numbers. But then you have to find a way to have a list or generate the prime numbers to begin with. This way is easy, okay? It is not incorrect. I did not ask for the most efficient solution, right? So any solution that works is going to be okay. All right, so we'll keep doing this for a while. And when I say a while, I mean a while.
Is it a prime number?
Hmm?
Is it a prime number? Is that why you picked it?
And, well, let's see whether it's a prime number or not. So you can see that none of these remainders is a 0, right? That's a 10, not a 0. So, and I have only tested numbers all the way up to 123, and I'm saying I have already tested too many numbers. Okay, because I really only have to test up to the square root of 5821, which is going to be less than 80, right? Because 80 times 80 is 6400 already. So in other words, I could have just stopped somewhere around here. Okay. Okay, by the time I get to 80, 59, or one of these numbers, I cannot remember which one, I could have stopped already. But why can I stop that early and determine that 5821 is a prime number?
A number should be guaranteed to have one of its factors that's less than the square root.
It has to be less than or equal to the square root of the number. Exactly. So it has to do with one little simple fact, that if you pick a positive number A, you pick a positive number B, and both A and B are, I think they have to be at least 1, okay? And you have a product of C. It is guaranteed that A is less than or equal to the square root of C, or A or B is less than or equal to the square root of C. That is guaranteed. So if that is guaranteed, that means if I'm finding the smaller factor of n, and 1 exists, and n is not a prime number, I would have come across it by the time I get to the square root of the number. So that's why I can stop that early. But that optimization is, once again, for the efficiency of everything. So without this optimization, then you would probably have to go all the way to 5821. And this is going to take a while. Depends on how fast we can scroll, right?
You should be able to double click on the little thing on the, see the little black dot here? If you double click, it should take
Yeah, it doesn't know
work
when to
as well.
stop. That's the problem. It doesn't know when to stop. So the first time you do it, you cannot just do it this way. Well, there is a better way to do this, which is copy and paste. So copy and paste is powerful because let me show you the power of copy and paste and exponential growth. Okay, so what I'll do is I'm gonna remove things that I have done already. And you go like, wow, but that's a waste of time. We just did this, and we are now removing it. Okay, so we'll start with this one here. Copy, paste. Oh, that didn't work. That's because this is actually a 3. It's not an equation, so I need to turn this into an equation first. Yep, so that will work. Okay, now let's go ahead and copy and paste. You go like, oh great, we won't be done by the time this class ends, right? Now we copy and paste. A little bit faster. We copy and paste. We copy and paste. Whoops, I forgot. Step, copy, paste. Copy, paste. Copy, paste. You can see how much faster it is now. It is exponential, right? It won't take long. I mean, this looks like it will take a long time, but it's not going to take a long time. We have copy, paste.
It would go faster if you wouldn't use your mouse actually. Well, no, there's a lot of keyboard shortcuts on there that you can use, and it actually would make it faster. But using a mouse,
Down there will make it
it's
bottom
not.
of this.
But that's the thing about exponential growth is even though I am slow, if my way of doing things is faster, it is still faster. Now, for those of you who took cisp360 from me, this is called the big O notation. Remember that? Remember the race between me and Pat?
Yes.
The binary search.
Yeah, binary search and all that stuff. This is it. Okay, we have one more paste and we are all done. And with this one, I don't even bother to paste from before because we'll get to 5821 in this one step. There we go. So we get to 5821 and make sure that's a 0, right? We don't want to make a mistake where okay, something went wrong. That would be embarrassing. But embarrassment is good. It's good reinforcement. I learned it better when it hurts. Yeah. All right. So, are there any questions about this approach? Okay. But this is just showing you how to do it by hand, and the point of not picking a number that is obvious. Because you pick a number that is obvious, then you're not going to go through all these steps and say, okay, systematically speaking, how do we find a factor of a number? So now that we have this kind of more or less systematic way of finding a factor of a number, it is time to write the code, okay, to actually write it in C++ code. So now we switch back to, okay, I'm going to get rid of all of this stuff here because it is from the previous class. So now we're going to write the code. Do we see any type of hint here that we need any particular type of control structure? Now when I talk about control structure, there are only really two main types of control structure. One is a branch, a conditional statement. You have a condition and you got two ways to proceed. But there's no going back, okay? Once you get past one branch, you continue with whatever is next to that statement. The other type of control structure is a loop, okay? You can keep doing the same thing over and over again until the condition is false, then you can get out of the loop. Which one do you think is appropriate in this case?
The while loop.
A loop, okay? Because, well, just the fact that I have to do a whole bunch of copy and paste is a good hint that I'm doing something again and again. There's a repetition in it, okay? Okay, sorry?
Did you say like while the mod doesn't equal 0, do the loop?
Yep.
You can just say all the month.
But I want to kind of do it step by step, okay? So we have a few components here, okay? So we know the variable n is important because it gives me the number and I want to find the factor of n. We know f is important because that is the variable that should store the factor. We know we have some kind of a loop here, so I just say while, okay? Do we know how we update the potential factor for each iteration? We try 2, and then we try 3, and then we try 4. We're just adding 1, 2. Yeah, we're just incrementing it. Okay, so we have plus plus f, somewhere that we have to do repeatedly. And what about the condition? What about testing to see, can we stop now? When do we stop?
When mod equals 0.
Okay, we have that expression n mod f, right? If it is 0 or not, that's what we need to know. Okay, not equal to 0 or equal to 0. So what I'm doing here is just kind of throw out all the components first, okay, and not really quite know how to connect all these pieces, but I'm just putting all the components out. Oh, by the way, f is uninitialized to begin with. It is clear from the question itself that f is not initialized. So I got to give it a initial value first. From the spreadsheet, do you think we know what to do with the initialization? 2 is a good one. Okay, so f gets 2, is a good initialization. All right, so now we have all these components. The one thing that we can start with is the loop itself, okay? Because when we say, oh, we have a while loop here, then we can automatically have these components, the condition and what to do for each iteration. Now, obviously, at this point, we don't really know, should we use a do while or should we just use a while? In other words, should we use a pre-checking loop or should we use a post-checking loop? In most cases, and I would say personally, of all the programs that I have written, easily 90% of the time it is a pre-checking. So if you're not really sure, then you can say, well, let's just assume it's a pre-checking loop. If a pre-checking loop doesn't seem to work out, then you can think about turning around and use a post-checking. But it is rare that you need a post-checking loop in general programming. Okay, that's good. What do we put in here as the condition of the conditional as the condition of the loop, as the while loop, pre-checking loop?
In mod f doesn't equal 0.
Yep, that's the condition. And by the way, in this case, I can easily remove this part, and it will mean exactly the same thing. Yep.
Do we also want to say and
Oh, to optimize it?
Yeah.
Yeah, let's not worry about the optimization part, because the optimization part kind of throws a wrench into how to stop the algorithm. So we'll leave that optimization later. Here's the row sheet. Thank you. Okay, so we can leave out the not equal to 0 part. Why can't we just leave that part out?
Expression has a value and 0.
Sorry?
That whole expression will return a value, and when it's 0, that'll actually get us out of that loop.
Yep. And it boils down to what C and C++ considers true. What is true in C and C++? Anything other than 0, right? And what is true when I say n mod f does not equal to 0? That it is not 0, right? So they're exactly the same thing. So that's why I don't really need to say not equal to 0 here. It is more clear to do so. Okay, it's definitely more clear to mention that the mod or the remainder is non-zero. Okay, it is not wrong. Okay, this really doesn't generate any extra code. It is simply making it more clear and say that we want the remainder to be non-zero to stay in the loop. Okay, which is okay. But you might see people try to write the same code but without the comparison to 0. Okay, I just want to make sure you understand their equivalent. Okay, there's no difference in terms of the meaning of the code. Okay, what about that plus plus f business? Where do we put it? It's what we do in the loop. Okay, because we only do that when this condition is true, which means, oh, okay, f is not a factor of n yet. Let's bump it up to the next value and test it again next. Question?
We technically can't have this space, right?
Sorry?
I said sorry to be
actually, you can have this space.
Good?
Yeah. But we'll try it. Okay. I don't trust myself either, but I think so. Okay. And then we have f equals 2 over here. That's the initialization. It has to happen before the loop. So now we have all the pieces in, and they all seem to be in the right place. So we'll go ahead and give it a try. We'll write a simple program to test it out and see if it works. So we'll go ahead and switch back to, oh, sorry, I think some of you are still talking from here. You can just type on the side here. And I'll just go ahead and make this program as simple as possible. So I will declare N, and I will declare F, and we'll just use a 28, what is it, 5821, which is a prime number. We found it, it's a prime number. I did not intend to find a prime number. I was thinking, what is the likelihood that I will find a prime number? The larger the number, the less likely it is a prime number. And go like, what? Cannot possibly be a prime number, and it turned out to be a prime number. Okay, now we write the actual code. F equals 2, while n mod f does not equal to 0. And by the way, a lot of times when I use extra parentheses, they are really extra. They don't need to be there. Like in this case, if I just write n mod f does not equal to 0, it will work just fine. Because the priority of the operators favor actual calculations like mod, multiplication, and stuff like that. And comparisons are less, they have less priorities. So they're evaluated later. But to be absolutely sure, this way there's no confusion, which happens first. F++, and this time I will make sure there's a space between the plus and the F and see if it compiles. And that's it. Okay, return 0. This will be fine. Okay. The compiler may complain about it. I don't think it will complain about it. So let's go ahead and run this program in GDB, because obviously it doesn't print anything. So we'll go ahead and say G++ -G -O F F.cpp GDB F. Say again?
Because it didn't complain.
It did not complain, correct. So we'll be brave and put a breakpoint on line 13 and assume the program is going to work correctly, right? Run the program, it stops here, we print the variable f in this case, and it is the prime number itself, so it works fine. Okay. All right, so are there any questions about this program? Questions? The one time, I do want to get back to the space thing. The one time you cannot have a space is when you have a plus equal, then you cannot have a space between the plus and the equal. Because plus equal together is an operator. When you put a space in between, then it becomes two operators, plus and equal, and that won't compile.
Okay, so then any single operator, like in this whole form, can take any number of spaces between its operators.
Correct. Yep.
How does this program know how to print f at the end of this as the final factor?
It does not.
Oh, okay.
That's why we use GDB.
Okay.
Yep. But GDB is a really great tool because it allows you to see how a program executes and examine variables at whatever point you want to stop the program. It is much better in many ways. It is much better than printing out the values of variables because it is much more, it's flexible this way. Right. So, any questions about this code? No questions? All right. If there are no questions about this one, let's move on to the next question in the practice exam. So the next one is X1, Q4, exam 1, question 4C, which is the third variation. So the format is pretty much the same as the previous one, except we're trying to find something different this time. N is an integer in this case, and it is at least 1. You are also given an uninitialized variable f, and this time you need to have one more variable to make this work. So you assume that you have x also available to you and use it as a variable in your code. Write the code to find the smallest value of f such that f factorial is greater than or equal to n. So, for instance, if I give you 10 as n, then you have to find me the smallest f so that f factorial is greater than or equal to 10. It cannot be 1 because 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. So the answer would be 4 in this case, not 24. I'm not looking for the factorial itself. I'm looking for the number whose factorial is greater than or equal to n. Is that okay? All right. So how do we write some program like that? Now, once again, it is good to do it a few times. Using just do it by hand. Okay. So let's say n is 100 this time. Okay. Then what you need to do is to say, okay, if f equals to 0, if f equals to 0 is okay, but 0 factorial is definitely less than 100. So we cannot stop yet. Okay. So let's try 1. 1 factorial is 1, which is also less than 100. 2 factorial is 2, which is less than 100. 3 factorial is 6 is less than 100. 4 factorial is 24. And guess what? The next one is going to work. 5 factorial is 5 times 24, which is 120. So 5 factorial is exactly 120, which is greater than or equal to 100. We can stop. In other words, in this case, the answer is 5. Is that? Yep, go ahead.
No, go ahead. No, okay, so there isn't an actual factorial operator, so we're just basically trying to...
That is correct. C has no factorial operator, so you will have to use your own code to compute the value of factorial. That's why you need a third variable to store the factorial of f as you increment f.
Can we do it the way that you showed us recursively? Find factorial and just loop that?
Well, we haven't really talked about subroutines yet. So if you want to do something like that, in the test, you can do it. But if it is wrong, I cannot say, well, since you use a more difficult way to do something, I'm going to give you some points just for being more, using a more difficult solution. So yeah, use the most reliable and easiest way to do it. Yep. Okay, so this is the method, but you can definitely kind of tell what type of control structure we need in this case. Do we need, okay, if I give you a pick, okay, a choice, okay, and you get to pick, do we need a conditional statement or do we need a loop? Which one would you pick? Are we doing something over and over again?
Yes.
Yep, definitely. Yep. So that means we need a loop. So once again, I'm going to throw out all the pieces so that we can kind of say, okay, now how do we combine all these pieces? First piece is f is not initialized. So how should we initialize f? 1. Yep. F gets 1 is one of the components. In the loop, what are we doing? For each iteration of the loop, okay, we are doing something about the potential f, which is the answer. What are we doing to f? We're just incrementing f. Okay, very good. We're just adding 1 to f each time. So plus f has to be somewhere in this program. We just said that we have a loop, so while is there. With while, there's always a condition to evaluate because we want to say, okay, when do we stay in the loop? And if this condition is false, we have to get out of the loop. So when should we get out of the loop? There's one variable that is not stored here, that's not explicit here. We'll just call it x. Okay, so x is the factorial of f. So when x, okay, assuming x is f factorial, then we also want to pay attention to the condition because we want to compare x to n. So if x is less than n, we stay in the loop. Okay, so the condition is important. What else is important here? How do we compute the factorial of f when there's no function to compute the factorial of f?
Subtract 1 until you have none left.
Well, we'll kind of maybe we'll defer that. Okay, so we're trying to be lazy here and just gonna defer that a little bit. Okay.
Multiply up
Would-
to F from 1 to F.
Okay, so we'll just do whatever we can here. Okay, the initialization goes before the loop. We have the loop, which is we stay in the loop as long as x is less than n. And in the loop, we just say, plus f, f gets incremented by 1 for each iteration. So obviously, this is not going to work. Okay, I can look at this right away and say it's not going to work because x is not initialized. Okay, fine, we'll initialize x. That's not a big deal. Now, since x is supposed to be f factorial, since we initialize f to 1, what do you think? How should we initialize x? What is the factorial of 1? 1, that's right. Okay, we got x initialized, so this has to work now. Well, only if you want an infinite loop. And this time, when I say infinite loop, I mean an infinite loop. Because f can wrap around all it wants, and it still won't change the comparison that does not involve itself. Right? Because, sure, f eventually would go back to 0, and then all the way to negative values, back to 0, back to 1, back to 2, and so on. I don't care, because the comparison does not involve f. So this is a genuine infinite loop. It really doesn't stop until you say Control-C, stop now. Okay, so that means we're missing something here, okay? X is not getting updated when it is supposed to be updated. So the question now is, okay, I know we are supposed to update x. Should we update it here or should we update it here? That is the question.
After the plus plus.
After the plus plus. Well, you can kind of do it before, but then you have to go through more stuff to make it work right. So it makes more sense to do it after. And if we do it after, obviously there's an assignment operation here somewhere. How do we update x?
X
So
times
that
F.
x, go ahead.
X times F gets X.
Yep. Because x has always been f factorial, so that means, before we increment f, x is still f factorial. Now that we have just added 1 to f, how do we update the factorial so that we go from what it used to be to the current factorial? Just multiply by f, because f itself is incremented already, so we can just do it this way. Now, for those of you who like the compound assignment operation, you can also make it this way. It means exactly the same thing. Okay. So I'll just kind of use a comment here to make sure that people understand that you can write it either way. And to be truthful, when you turn this in as an answer to your test or as a homework assignment, either way is fine. Whatever way makes more sense to you is okay. I would say x equals x times f is more universal because you can do it in Visual Basic as well as in any type of C-derived language. The other way, which is x multiplied equals f, is only doable when you're dealing with C, C++, and most C-derived programming languages. So I would pick the second form just because it is a little bit more universal. But the first one, the way it is right now, is correct. I cannot take any points off. And that's it. That's the answer. Because by the time the loop exits, x is guaranteed to be greater than or equal to n, which meets the requirement of f factorial is greater than or equal to n. All right. Are there any questions about the programs that we have talked about so far?
So you're on the test, you're looking at it to write it like you have on the screen right now. You don't want us to say an int main void and do all that stuff, just what we see right now.
Exactly. Just that code, there's no need to give me the main and stuff like that. It's kind of like a homework assignment. You can kind of assume that there's some code before yours and some code after yours to utilize the answer coming from your code. So you don't have to worry about, okay, how do we initialize n? Well, it's already initialized by the time we get to your code. And how do we make use of f? Well, it's after your code, something is going to utilize that. Yep. All right. If there are no questions, that's the end of today's lecture. You have a new homework assignment. and you have to study for the exam. It's on Monday. It's open book, open notes. It is on paper, unfortunately, even though we could have used computers here. I'm not going to use computers for the test. So it's going to be paper-based. It is open book, open notes. You can bring anything that you think will help you, as long as it is printed or handwritten prior to the test. Any questions about that part? Is anyone going to roll in like a whole big stack of C, C++ programming books? No?
So after you write your code block program, what do you do to get it to run? Because I did build and then run and then just nothing happened.
You can actually hit F8, it'll do both.